Hi there.
Hi.
Yeah. Okay.
Hi everyone. How's everyone doing?
Good.
Good. See, we've got a couple of.
Yeah, thank you. Thank you for inviting me.
Not at all. Thanks very much for coming along, Alan.
I hope everyone is excited to get engaged. The requirements for building a robotic arm, were they sent on to the
They
student?
were, yeah.
Yeah.
Yes,
Excellent.
they should have been sent on. With they're in the description of this as well. They're in the description of this as well. But we can run through them now for anybody, just to make sure.
Sure, and it's important to note as well for any of you guys out there, you know, you don't have to have the exact requirements. It's whatever fits the job that is necessary as well. So if you have something else to hand that might actually work, then, you know, grab it and use it, kind of scenario. Okay.
I've done that.
Have you built a robotic arm?
No, she doesn't. Yes.
So, okay, so we'll spend a couple of minutes talking about how to build a robotic arm, and then I'll spend a couple of minutes talking about how that moves us from where we are here to where we are going into future missions and whatnot. So, Fiacre, over to yourself.
Brilliant. So I think we'll head on anyway. We'll get started. And Sarah, if you just want to keep an eye on the teams, just to make sure that nobody's joining that one by accident, just in case. Thanks very much. So just to kind of introduce ourselves first. I'm Fiacre. I'm working with Sarah, Mark, and Kevin and Susan here. On putting this program together. I know there's a few friendly faces here already. But just for anybody who's new, do you guys want to introduce yourselves?
Thank you. Okay. Introduce yourself. What's your name? Go on. We have two shy kids here. Go on. We have Cara Clerkin. What's it, Cara? Hi.
Hi.
And we have Hugh Clerkin.
Hi, Karen. Hugh. How are you doing?
Hi everyone.
This is my robotic arm.
Oh, very nice. Very nice. And what's your name yourself? Hello, can you hear me? That's all right. And then I see we've got one other person here as well, and I recognize you from last week, but I can't quite remember your name. Hello, it says Kavita Kavi on the team.
My name's Babusha.
Babusha, is that right?
Yeah.
Great stuff. Great. Well, great to have all of you on board. Before we get started, and I'll hand you over to Alan for the guest session with Blackrock Castle. I'm just going to continue on with our story. So for any of you guys who were here last week, you'll remember that our astronauts were flying through an asteroid field. And they got out the other side of the asteroid field and they landed on Mars. And then you guys played a bit of a game to land your rocket on Mars. So our astronauts are actually after landing now. They've landed on the planet, and you're just going to watch a quick animation to see how they're getting on with that. So if you give me 1 second, I will flick over to that here now. So that's where our astronauts are at now. They've landed on Mars, and there was a bit of an accident with an alien spaceship. So they're going to need to build something to lift the spaceship up off the ground on Mars. And we're going to build a robotic arm to help us with that. So with that, I'll pass you over to Alan, and Blackrock Castle will take over for the next while with the rest of the session.
Thanks very much, Rika, and welcome all. I know some of you might have built a robotic arm previously, but hopefully you'll build another one, because when you're on a mission, you may need to do repairs, you may need to build a new one, you may need to upgrade and whatnot. So it's good to have the engineering tools to be able to adapt to any scenario. So first of all, let me just introduce myself. My name is Alan Giltonen. I work at Blackrock Castle Observatory. We do a number of things down here. Some of it is astronomy related, and some of it is what's called Space 4.0 related. So Space 4.0 is all about space technology and looking down as well as up and so on. I'll get more into that after, but for now, I think let's crack on. If anyone has any questions at any time, okay, don't be afraid to ask. Okay, just put your hand up or just interrupt and ask any questions. Okay, there'll be no problems. Okay, so if I can share my screen. I need to be given, Fiacre, can you give me screen share access, please? Garmagat. Right, so I'm going to give you guys, I'm going to introduce two colleagues of mine, Francis and Danielle. Okay, so they're experts in building this robotic arm, and I hope most of you do have the tools to hand. If not, don't worry about it. This is also available on our education channel on YouTube, so you can always look at it again afterwards and take your time building it in your own time. Okay, so I'm just going to play this video. Can you see my screen? I'll take that as a yes.
Hi, I'm Danielle.
Can
I'm
indeed.
from the Cyclone team, and I am here today with Francis from the education team. And we're going to go over some really cool activities to do at home. Things that you can use around your house to create some really interesting things like, what are we doing today, Francis?
Today, we're looking at being robotic engineers in space. We're going to make and design robot arms and then test them and see how well they work.
Make a robot arm in your own.
Make a robot arm.
Yeah, really cool. So, all right, so what do we do?
Okay, so this robot arm activity, we're looking at one of our Space Week activities that you can find on spaceweek.ie, and it is engineering in space, all about astronauts aboard the International Space Station, and this is part of the Mission X project. You can zip over to sro.ie, find their page, and that will take you onto Mission X if you want to take part in the full project. Now, throughout this, we're going to be taking an inquiry approach. So asking questions, engaging interest, carrying out an investigation, and then figuring out other next steps we can take. So our first question to really get us engaged and get us interested is a trigger. What is cool about this? So look at that picture, Danielle. What do you see?
Well, the first thing right away is the astronaut. And
Yes. So she's called Samantha Cristoforetti. She's a European astronaut. And this photo was taken when she was on the space station, which she was between the end of 2014 and the beginning part of 2015. So 199 days in space.
oh my gosh, that's amazing.
Just so much fun. Where is
The
she?
first thing
What
I
is she
noticed
doing?
was her hair floating, and you could just tell that she's in space. And it looks like she's doing photographs. Is that what it is? Photography?
Yeah, so she's got the camera in her hand and she's looking out the window of the cupola. So that's
Really cool.
the window area aboard the International Space Station. So she's looking out and the Earth is below. So just to one side of the screen, you can see the Earth. But in the screen, that's the end of the robot arm, the Canada arm, that is the workhorse of the space station. It's how the space station was built. So there's a robot arm that is controlled by the astronauts and moves everything around.
How cool is that?
Oh, so cool. Okay, so we've got the idea that these robot arms exist used by astronauts to control and move things when your own arms couldn't reach. Like you can't reach outside the space station.
Right.
Okay, even if on a spacewalk, you can't grab a big thing and move it around. So you make a robot arm to help you. We're going to make our own robot arms. So
Like the
this
one
is
from the
part-
space station.
Yeah, this is part of engagement. Now, this is a simpler robot arm than the space station.
Okay.
But it still has the idea that we're going to be at one end of it controlling it, and it's going to move and adjust and move something at the other end. Now, there's a how-to sheet in our spaceweek.ie resource, and it shows pretty straightforward that you're going to use lolly sticks.
Okay.
Okay, so I got a couple of lolly sticks here. I think you've got some lolly sticks as well.
I do. Mine look a little different than yours.
We're going to need to join these lolly sticks together. Now, two will get joined in the middle, and obviously my lolly sticks can't join because my lolly sticks are completely solid. But if we punch a hole in them, then we'll have a hole that we can use to attach them together. And the brass fasteners, kind of split pin fasteners, are a great thing to use. But you may find the end of a twist tie if you have the, if you might have some plastic bags that come with twist ties, perhaps that would work, or something else that you can figure out. The idea though is you're going to join them and they're free to move over each other because we want to be able to adjust the length of our robot arm and be able to pick things up with our robot arm. So, hole punching time.
Okay.
Now, in the best stuff, we've already done quite a bit of the hole punching to have it already done.
Yeah.
If you find that the lolly sticks are a bit tricky to get a hole punch through, do you think something else would work? Jet screws, cardboard screws. So you can try and find out which kind of works the best for you. So how are you getting on making yours, Danielle?
So I've got some lollies that already have pre-holes punched in them already, pre-hole punched. So I did the X's like you said.
Okay, yeah. So
Put fasteners through. So I've got 2 X's on top of each other.
okay. And then you're going to attach 2 X's to each other at the edges.
So put the little fasteners through.
Now, you may need to decide, does the one on top of the X be the top of the next X, or does it have to need to be underneath? Because, they do have kind of a sideways width. Look at it on the edge. So there is kind of a top one and a bottom one.
Right, yep.
And a good kind of maths puzzle for you is if there's 3 holes in each of them, how many split pins do you need?
So to figure out your supplies in advance.
Yeah, do you need 3 for every single one? Because 2 go into the same split pin, is it a different way to work it out? And there's a good kind of maths puzzle in that to work out how many do you actually need. Now, of course, you can look at our diagram and count it. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8 lolly sticks, and I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 split pins.
Oh, for the full arm, the one you have there, okay.
If you're doing the full thing. Now, we'll just make a shorter one, just kind of 2 parts of it.
Yeah, I've got 2 X's done, so this is what mine looks like now.
Oh, perfect. Now, if you put one end of the 2 that are joined to the same X and try squeeze
Like that. Yeah, moves pretty
you
good.
see that the far end opens and closes with your hands opening and closing.
Yeah, that's really cool.
Now, you've seen how it works. And so that's the first part of our inquiry, is I wonder how it works. Now, how can we find out more about this? We've made our robot arm. How can we make it work better? So there's lots of possibilities here. And the best thing to do is to explore by using it. What happens if you make it longer? What happens if you make it shorter? Does it work if it's only one?
Yeah.
Put more on it. Is it easier to work with a longer or a shorter arm? Do you have grippers? Do you have something on the ends of these that can help you pick things up? So if you think, okay, you need a little bit of friction to be able to grab with the end of these robot arms. So did you want to add something to those? And you could add, say, a bit of rubber. You could put a masking tape on it, maybe with the sticky side out. There's lots of possibilities. And exploring that is finding out.
Ooh, let's add another. Look at that.
Oh, you've added another one. So is that as easy to control? Does the end seem to close up as well? Have you tried picking anything up?
So I have a little bit of you mentioned having something for the end. So this is some rubber at the end of your pencils. We'll put that at the end.
But you could try it with the grippers, without the grippers. Do they make a difference?
Okay, so this is definitely more difficult to get the longer, because they have
Now, what could you try and pick up with this? Do you have any small little objects, like a little bit of Lego or beads? I've got a little dice here, so something small that will be picked, that you can pick up.
Little lollipop, we'll see if we can get that. I've got a here. And, oh yeah, these are small, so let's see if we can get this. Okay. This might be a little bit tricky. Let's see. Woo. Oh, it's tip. Oh, hey!
Well done. So all of this is what we call exploring. This is finding out about what's going on and getting to experience with it. Once you've explored and you have a sense of how this works, you can actually ask an investigation question. I wonder, how could we improve the design? And that's a really open question, and everybody might have their own ideas. So you'd predict your idea, and try it out and explain why you think it would make it easier or harder to do. And that's a science inquiry that you've designed and developed all on your own. And really, it's up to you what you want to ask. Is it better to be longer?
There's a lot of possibilities. Yeah.
All sorts of possibilities. And this is what we're saying. I mean, making them is fun, but then investigating with them is really getting into, I wonder what's going on and why does it make a difference? And you're learning science by doing it. Now, the real robot arms, here's one that's due to be launched later in 2020. So here, instead of having lots of hinges, we've got a wrist, an elbow, maybe a shoulder, a wrist, an elbow, and then there's a grabber on the end.
Yeah.
And this one hasn't even been sent to space yet. It's due to be launched at the end of the year. Yeah. And when you carry out the investigation, you could change one thing, try to pick up the same materials. Because is it fair if you say, oh, it works really well on picking up my alien, because he's got all the bits sticking out of him, but it didn't work as well picking up my dice. Well, your dice have the things sticking out of it. So you need to be thinking about a fair test that you're picking up the same each time. What are you measuring? How long it takes you to pick it up? Are you measuring how far you get it before you drop it? So these are the ones to measure, and does it help you answer your question?
Yeah, even like how tight you fasten the lolly sticks together. Like if it was tighter, it'd be a little sturdier, but then it might be harder to actually move it.
Yeah, okay. So there's a prediction and a reason, and then you can go out and find out if that's valid and true.
Yeah.
What if you tried something else? So if you didn't have lolly sticks, could you try it with cardboard?
Yeah.
With cardboard, it's pretty easy to change the length of the cardboard. You have long cardboard, you can have short cardboard. You could try maybe putting the holes in slightly different positions. Does that make a difference? And those extend the investigation.
Oh, okay, yeah. Okay, cool. Yeah. So putting the holes like closer together or something like that. You could have there's a lot of different options then.
Yeah.
Very
So
cool.
have fun investigating and finding out.
Yeah, especially with being home, there's a lot of different objects around the house that you could try to experiment with and see, is this too, like I was just looking across, I have a little tray with stones in it. Like, would those be too heavy to do? Maybe that's something to try. So yeah, I can see a lot of different options and possibilities with this one, Francis. So much for that one. That's fantastic. And for more information, make sure you check out our website at bco.ie for more resources there. If you have any questions, of course, leave them in the comment section for us, and we'll get back to you as soon as we read them. Thank you so much for joining us. See you soon.
Hi guys. Well, I hope you had a nice time enjoying. Let me just close down a particular site. I hope you had a nice time doing that. Some of it is going to take a bit longer. It might take you, a couple of hours to put together, but as mentioned, it is on our website. So do tune in, and you can go through it at your own pace, whatever suits yourselves. What I'm going to do now is I'm going to step you through the importance. Oh, and by the way, two things that quickly came to mind. First of all, from yourself, Yurka, I liked the way that the Martian lander came down in the SpaceX landing scenario. From an engineering point of view, very interesting and very appropriate. So I liked that part of it. But also the robotic arm that Francis and Danielle were mentioning was actually launched at the end of July of this year Okay, so there were some technical delays, but it was actually launched, and it is actually up in space at the moment. It's going through a whole calibration side of things at the minute, but it has been launched. Now, when we talk about space and space exploration, okay, so I'm going to go into a slideshow in a second, and I'm gonna talk about things. Okay, I'm gonna talk about space, what's called Space 4.0, as I mentioned earlier on, and I'm going to talk about what we do here at the observatory, which is the astronomy side of things, supermassive black holes, extrasolar planets, that kind of thing. Okay, so and as I said, if you have any queries or questions, please don't hesitate to just blurt it out, okay? Because don't be afraid to ask questions. So if I can share my screen again. This one, I think. Yes. Right, you can see that, I assume. Right, so now we get to the interesting side of the business, which is the fun side of the business, which is astronomy and space exploration to another level. Okay. So to follow on from what Francis and Danielle were doing, okay, there's primarily two projects on the run at the moment. Although there's technically three. There's a Russian Roscosmos as well. One is from SpaceX, and one is from a combination of NASA, Europe, and Japan. Okay, so Artemis is going back to the moon. So an important part of building a robotic arm is actually the capacity to actually do things in space, but also on other planetary bodies. Okay, so Artemis is going back to the moon in the next five to 6 years, hopefully, maybe a small bit longer than that. But when you go to the likes of the SpaceX project and you're going to the likes of Mars, if you want to go a bit further than that, then you need to think about other things. And I'm going to give you just a quick look at a model of a rover. Okay, and you can see the robotic arm, the exact same robotic arm that was designed. It has the elbows, it has the swivels, it has all that kind of, okay. This is the kind of rover that is going to be going on Mars.
Rover.
Pardon?
We can't see the rover.
You can't.
Yeah.
Can you see that?
No.
All right. Can other people see it?
Yeah, I can see it. I can see it, Alan. I think you have your presentation is maximized, and some people might have their settings so that they're only looking at the presentation.
Okay. Well, I can stop sharing momentarily. Can you see it now?
Yeah.
So you see the arm. Now this actually has a drill in it, and the drill is actually very important because if you go to Mars, you'll need to be able to drill because you want to get at the ice underneath. Because does anyone know why ice is so important? If you're on Mars,
It's frozen water.
it's frozen water, which gives you two things. Do you know what they are?
Hydration and some.
Absolutely. So it gives you the capacity to create fuel and oxygen. Two kind of very important things for humans to be able to survive on the likes of a Martian surface. Okay. Let me just go back into my PowerPoint. So the ability to be able to create a robotic system is very important, because it's not always the case that you will be able to do that. In the event of not being able to do that, you need to adjust. So knowing the engineering behind it is very important, okay? And as I said, these two particular projects from Artemis and the SpaceX project are looking to go both beyond. However, there is one more project which is of particular interest, and in particular for you guys, okay? So there's a European Space Agency lunar village being looked at the moment. And they're looking to build a lunar village in the next 15 years or so. So that'll be right around the age that you guys are at the moment, when you will be flying to the moon and living on the moon for extended periods of time. I mean, how cool would that be? But so just keep it in mind. Sorry, that's not highlighted. Okay, so another aspect of the whole space 4.0, okay, and I'm going to divert slightly from the robotic arm slightly, but only momentarily, okay, is Earth observation. Okay, so we all know how important it is to look after the Earth, the atmosphere, the water, everything encompassing our Earth. It's very important. And there are a number of projects that actually look at this. The Sentinel projects are probably the most prominent one. Okay, so that's a project called Copernicus, named after a famous physicist. And it looks at all of the temperatures and the pressures and whatnot of the actual Earth itself, okay? And then it gives us the feedback for us to be able to say, okay, this place is getting warmer, this place is getting colder. And it allows us to be able to try and predict the weather patterns that we actually have in a long-term and short-term scale. It does go down to 1 centimeter resolution, by the way. So if anyone has any phone and you are out and about, it can read your phone. Cybersecurity, I won't go into, because it is important to be very aware for all of you when you are on any cyber system, which is any system like we're on right now. There is security required. Very important. Okay, so always be very, very mindful of ensuring that your passwords are safe and all that kind of thing, because it is very important. Okay, there is a whole new thing in terms of space cybersecurity, and in the next 10 to 15 years, that's going to become even more relevant, because all of this data that we transmit that goes up and down and across and all around the world is actually going to be very, very intense, but also has to be secure. You don't want anyone looking at what you're sending. So you need to be secure. So actually, Ireland is one of the cyber security space hubs in the world. So we have a number of security companies in the region, but also Munster Technological University is also the core of Space Ireland, Cyber Ireland. So we have a tradition down here in terms of making sure that everything is secure and safe, and all traffic, internet traffic is safe. I want to talk about small sats for a second. So does anyone know what a small sat is? Anyone? No? I'm getting one thumb down.
I have
Any
no
more
idea
thumbs?
myself,
Any
Alan.
thumbs up?
No idea here.
Okay, so a small sat is a low Earth orbit satellite system. Okay, and actually, this does actually lead in to why robotic arms are also very important. All right, so a low Earth orbit satellite system is tiny, as you can see. I mean, it's 10 by 10 by 10 centimeters. Okay, so it's quite small. Now you can get them in stacks. Okay, so you can have 2 or 3 of them together, but generally no more than that. All right. What they do is they're providing satellite internet as well as looking at the planet from an environmental point of view. Okay, so they're providing internet to countries all over the world, including people in rural locations and Africa, Asia, South America, rural Ireland, and so on. Okay, but they're also then, some of them have imaging systems and sensors that look at the planet itself, and that's where we get the heat maps from, and the level of the ocean and all that kind of stuff. But they're tiny. They're tiny, and they actually don't go up too far into space. They're 200 to 250 kilometer kind of region. Some of them may go up to closer to 500, but not too many of them go up that high. The bigger satellites, they go further out, just from a physics point of view. It makes more sense. So these particular satellites, you can see they're quite small. They're quite small, but they're quite powerful. And if you have enough of them out there, can anyone name any low Earth orbit satellite systems? Anyone?
Low summons.
Okay. I'll give you a hint. Elon Musk. Anyone heard of him? Yeah, okay. We've one tongue.
He's SpaceX and Tesla.
Correct.
He owns.
Correct. So his satellite systems are low Earth orbit systems. And they're all about 2 to 3 times the size of what you see in the picture there. Okay. So they're very small, but they're very powerful. And they send it all back down through radio frequency, and you can see how small they are compared to some of the bigger satellite systems that are out there. But because they're low Earth orbit, and this is one of the reasons why it's so important for the robotic arm side of things to be available, is there's a number of companies who are looking at designing. In fact, one of them from South Africa are building a robotic arm that actually can you see those circuit boards? Can you see the green circuit board? So they're looking at an infrastructure. So they're looking at something that can take some of those circuit boards out and put in a new one, because computers get old or they break down. So you need to be able to replace it. So instead of bringing it back down to Earth, it might be easier to actually simply replace it up in space. So you'll have a single mission that will go up and it'll replace a whole load of those little circuits and give you a completely new computer system up in space. Now, you need a robotic arm to be able to do that, because you can't simply go in physically from a human point of view and do that. That ain't going to happen. You need a robotic arm to be able to do that, and you need a robotic arm that is actually very, very, very precise. So it's a very interesting thing, but it's going to be very important going forward, because you'll need to be able to do it not just in space, but you'll need to be able to do it on the moon and on Mars, and further out beyond Mars as well, when we start exploring out there. So the space cloud, okay, I won't stay on this. Space cloud, how many people here watch the likes of Netflix or YouTube or what Zoom that we're on now?
I do.
Yeah, we all do, don't we? So space cloud is an interesting concept, and it's brought forward by a number of companies, right? Imagine if you had all of what you watch up on a satellite, as opposed to it being down on the ground. You'd have no delays, no lags. It would be instant. How cool would that be? That would be absolutely cool. On your phone or on your tablet or on your laptop or whatever device you're watching it on. So there's a number of companies who are looking at actually storing all of the internet traffic up on a satellite-based system. Okay, now that's a big ask, because there's a lot of information out there. There's a lot of information. So it's a big ask, but it's an interesting concept. But it's an interesting engineering concept, because it is technically possible. So it's trying to, again, from an engineering point of view, it's trying to figure out how do we get there. One of the main reasons, and then I'll go into the astronomy side of things, and I'm aware that we're probably getting close in terms of time. Fiacre, sorry.
No, you're fine. You're fine. You got plenty of time left.
So another interesting element is how quickly you can move traffic if you go through space. And this is a very good engineering project, by the way. Well, physics and engineering simultaneously, because you need to get the orbital elements right from a physics point of view, and you need to get the engineering side of it correct from a manufacturing point of view, okay, and making sure that the actual satellite itself is as best as it can be to get the signal from one side. So for those of you who don't know, light travels 47% quicker through space than it does through fiber. So you know your fiber at home, which you are probably, most of you are probably on at the moment, is actually slower than going through free air or space. So the best way to do it is to actually go up, over, and back down. If you want to talk to someone in America or in Asia or Australia or whatever country, whatever other area, even in Ireland, it's actually quicker to go up and over than it is to actually go through the fiber system. So, you know, putting these satellites in place is actually quite important from that point of view, because it not only does it give better coverage globally for the planet, but it makes it faster. It gives extra capacity, it gives extra ability in terms of if the fiber goes down or if the fiber fails, you still have the satellite system, so it gives extra elements. So basically you have a backup system, so it has all this going for it. So okay, so it's quite important, but that then goes back to having the robotic arm system, because can you see all the white little dots? They're all the satellites. See how many satellites there potentially are. So all of them may need replacing at some point, or they need elements replacing. So that goes back to your robotic arm, being able to replace the elements and upgrade them and make them new and fresh and reusable again, and to get the highest signal that you can from that particular satellite. Okay, so it is quite important. It's also quite important from a business point of view, but I won't necessarily go into that today. Now I'm going to get into the real fun side of things. And Fiacre, if there are any questions in the chat room, because the chat room isn't coming up for me, then please shout out. There's no problems. Please feel free to interrupt me.
Nothing I can see so far anyway, Alan, unless
Okay.
anybody else has any in private message. Does anybody have any questions, or has anyone been asked any questions?
Well,
All
if
good?
anyone does have any questions, then please feel free to ask, okay? So now I'm going to talk about some astronomy. Okay, do we all like astronomy? Am I seeing thumbs up or thumbs down? Thumbs up, hopefully. Okay. So I won't go into this in too much detail, don't worry.
Thumbs up. No, thumbs up.
No, you can do a thumbs up on the screen. I'm okay with thumbs up on the screen. Thumbs up on the screen is good. Okay, so we down at the castle, we have a big telescope up on the roof, okay? We have a very special name for her. She's called Big Bertha, okay? And what we do with Big Bertha is we look at a number of different things, okay? And I'll briefly talk about them. And if you have questions, please ask. So we look at quasars, which are active galaxies. So from a galaxy point of view, there are a number of elements to it. Okay, so some of them are very active, some of them are not so active. In fact, a very interesting thing happened recently, whereby we thought the center of our own galaxy had a supermassive black hole, but now we're not so sure. Now we think it might be what's called dark matter. So interesting, very, very interesting, because it's not something we would have considered previously, but some new data, but new data using computer techniques have analyzed the center of our own galaxy, and our own galaxy actually might have dark matter at its center as opposed to a supermassive black hole. So I look at supermassive black holes myself. That's my kind of area, as well as near Earth objects. And does anyone know what a near Earth object is?
Anyone have any guesses?
Near Earth object. No guesses? Okay. So it mostly it is asteroids and meteorites that are coming in and around the Earth. Okay. And extrasolar planets are planets that are outside of our own system. Okay. Our own solar system. So they're trillions and trillions and billions of miles away. Okay, so they're way, 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 way. So we look at supermassive black holes, and they are all outside of our own galaxy. They are very powerful. They're huge. Okay, so they're tens of times the size of our own galaxy. Now, if you think, does anyone know the size of our own galaxy? Okay, it's approximately 25,000 light years in radius. So it's large. Okay, there's billions of stars. Does anyone know the size of a star compared of our own sun, for example, compared to Jupiter or Earth? Did you do that in school?
Like 20 times bigger, isn't it?
Compared to Jupiter? So you can fit approximately 1,000 Jupiters in the sun. So it's quite big. And if you consider that there are billions and billions and billions of stars within even just our galaxy, then you get an idea of what we're doing here. I won't go into relativistic particles. Thanks for the response. Smiley face, less than 3 is all I can see. Rhyme intended. So I'm just going to give you a very quick look at, these are actual images, okay, of some, now these were taken by the Hubble Space Telescope. Now you can see, like, our entire planet system would, you see the image on the right hand side that kind of looks like a donut? Our entire system would fit way inside that. Now look at how small that is compared to the actual galaxy itself. It's tiny compared to the huge galaxy. Now this is radio. Well, it's a combination of optical and radio, but it's huge. And this is just one example of a supermassive black hole. And there are just so many of them out there. For any of you guys out there, right? What will you do me a favor? I'm going to give you an assignment, okay? I want you to look up the Hubble ultra deep field image. Ultra deep field image. All right. And I want you to draw it out on paper as best you can. Okay. It's all sorts of different colors, all sorts of different shapes and sizes. Okay. Will you do that for me, please? Thank you.
We'll have some prizes going next week as well, guys, for anybody who can do that and send it into the email or the SharePoint here.
What are the prizes?
We got lots of cool prizes actually from the Blackrock Castle Observatory. So Alan, actually, do you want to talk about some of the prizes that we might be able to give out to the guys?
Sure. So some of the prizes are so we've some European Space Agency hoodies. We have some teddies. We have some pens, pencils. Actually, we have a carbide pencil, which is designed specifically by the European Space Agency. So that's cool. And trust me, I'll try to use it. Oh, it's actually tough to use, so you'll need some practice on using it.
What's the thing called again?
The
How do you get them?
Hubble.
The
Okay, so forget about Hubble. Okay, if you're putting it into a search engine, if you're putting it into Google or whatever the case may be, ultra deep field.
I sent it into the chat there as well, everyone. For anybody who wants to read that or take a note of it for the week.
And I'm going to be the judge. Okay, so I want it good and accurate. So in terms of near Earth objects, just to give you a very quick overview, because we are out of time. You can see how on the left-hand side, we didn't really know that there were too many objects out there, and then by the time it came to by the noughties and the 2000s, we realized that there was actually a whole lot more out there than we realized. So yep. So this is the telescope at Blackrock Castle. Okay, so this is what we use, and we've actually used this specific telescope to look almost halfway across the universe. So we've looked over 4 billion light years away.
Hi, Vibhusha. Do you have a question?
Yeah, what do we draw?
Pardon?
What do I draw?
What do you draw?
Yeah.
So what I would like to see is if you look at the deep field image, you'll see a whole load of galaxies. All right. Now, some of them will be stars. The ones that have the kind of cross, they're going to be stars. They're closer to us. All right. That's called a diffraction pattern. So so they're going to be closer to us. But almost every other dot in that image is some kind of galaxy, and each one of those galaxies have billions of stars. So
Okay,
what I
so-
would like you to draw is, if you look at it, and there's no right way or wrong way, by the way, you can flip it, you can rotate it, I don't mind, because when you're in space, there's really no up and down, is there? Because you're floating. If you're out in microgravity, there's no real up and down. So whatever way you want to draw it, but take the points. Some of them are going to be, a certain distance apart. If you can keep kind of some reflection of it, but other than that, it is completely your choice. You can draw whatever way you want.
So I draw a galaxy with lots of stars.
Perfect. Yep, absolutely. I want at least. Can you do me 2 galaxies on the same
Okay.
sheet? On the same sheet.
Okay.
And do you know what you can do? If you have to see, the way galaxies spiral. You know the way they have a spiral kind of. If you can do 2 of them spiraling and coming into each other, how about that?
Okay.
Brilliant.
And you have all week to work on that Vibusha as well. So
Yeah.
no
Yeah,
problem.
you've plenty of time. I will not go into this. I won't go into photometry.
Yes.
Something like that. Yeah, that'd be beautiful. If you could just, can you colorize it and put lots of stars and all that kind of stuff in it?
Okay.
I want lots of stars. Lots of stars.
I looked up something a minute ago, and
You've a week to work in it, so there's no time.
It has a face of a tiger on it in a galaxy. Yeah.
Face with a tiger on it.
Yeah, it wasn't a tiger. I think it was a panther. Let me see.
Okay. I'm trying to think of a tiger reference. Not sure there are many.
That's a new one for you, Alan.
But do you know what, guys? Just draw what you would like to draw. Okay. I would say look at.
It wasn't
If you can have ask your parents or guardians or whatever to potentially look up the Hubble Deep Field Image and just have a look at it. If you want to make patterns out of it, that's perfectly good too, because you will see patterns in it. You will see what looks like 2 eyes and a nose and a mouth and all that. If that's what you want to do, then that's what you want to do. That's perfectly okay. Okay. But I want to see some spiral galaxies, and I want to see some clusters, and I want to see some other stars, and I want to see that X. I want to see the diffraction. Okay. If I can see all of that.
I put the stars inside.
Inside, yeah. The stars all go inside the circles.
So, so just for you guys, because you guys are left in the call now, Vibusha, Cara, and Hugh, I just sent the Hubble Deep Field image into the chat. So if you go into the chat, you'll be able to see that. And then if you open that and if you save that, then for the week you can work on making that poster, making that picture, and then you can send it on to us, and Alan will judge the best one.
Yeah, actually, Kavita, your arm is actually not underrepresentative of what deep field image looks like.
It's close, actually. So did everyone get that that image in the chat? Can everybody see that?
No, we didn't. And
Oh, you didn't get it, did you not?
We did get it, but we can't go in. We can't go into it.
Okay. Okay. Well, I'll tell you what I'll do. I'll send it out in an
Yeah.
email to everyone.
I'd say it's because it's a
Can you
JPEG,
help me?
so
You
they may
okay?
not have save access because it's
Okay.
a JPEG.
Hi, Vibhusha. What's up?
URL, I'd say.
Tapping. This into chat and I see 3 messages.
Yeah, I think the image won't send in the chat, but what I'll do is I'll send it on to an email, in an email to everybody, and then I'll send you. I'll just put in the email here. So if you guys have any questions at all over the week, you can reach me at this email address here now. So you can reach me at that email, and I'll send out an email to all of your parents anyway, and then you'll have this image. I'll send this image to your parents or your guardians email address, and then you'll be able to draw the photo and send it back to us at that address. Is that okay with everybody?
And don't forget the Ultra, or don't forget Mission to Mars. This is what it's going to look like. This is going to be the rover that's going across Mars with humans in it. It's actually a very nice model.
Amazing, isn't it?
So it comes apart. It has your solar panel. It has your little astronaut. So this is what it's all about ultimately. Exploring the universe.
Brilliant. Brilliant stuff. Okay, thanks a million for that, Alan. That was great. That was great. I hope everyone here enjoyed that. And this recording, as always, this meeting will be recorded and it'll be available for everybody to watch on the SharePoint for anybody who wants to rewatch it. I hope you guys were able to. I hope you guys enjoyed the lesson and as well the tutorial for the robotic arm. I don't know if you guys have all the material you need to make that, but the recording will be there on the SharePoint again for all of you if you want to rewatch it or if you need to rewatch it to learn how to do it. Yeah, that's everything we have time for today, I think. So unless anybody has any more questions, we can leave it there, and we'll see you again next week. Everybody happy with that?
Yep, great.
Great stuff. Thanks again, Alan. That was brilliant.
Thanks,
Great.
everyone. Lovely to meet you.
Thanks a million. All the
Thank you.
best.
Bye.
Cheers.
Bye-bye.
Bye-bye.
Hi.